Tired of code that behaves like a rebellious teenager? You know the kind, unpredictable, hard to manage, and always causing trouble when you least expect it. It's like trying to tame a wild beast, and no matter how much effort you put in, it just doesn't seem to get any better. You're constantly firefighting, fixing bugs, and trying to make sense of the chaos. But what if I told you there's a way to bring order to this madness? Enter the Solid Principles to the rescue. These principles are like your coding superheroes, ready to save the day and transform your code from a tangled mess into a well-organized masterpiece. They provide a set of guidelines that help you write code that is not only functional but also clean, maintainable, and scalable. Imagine having a toolkit that empowers you to tackle any coding challenge with confidence and ease. Solid stands for 5 key principles in object-oriented programming that help you write cleaner, more maintainable code. These principles are the foundation of good software design and can make a world of difference in your coding journey. They are single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Let's dive into each one and see how they can transform your coding practices. First up, single responsibility principle. This principle states that a class should have only one reason to change, meaning it should have only one job or responsibility. By adhering to this principle, you ensure that your classes are focused and cohesive, making them easier to understand, test, and maintain. Think of it as giving each class a clear and specific role, just like a well-defined job description. Think of it like a Swiss Army knife. Each tool does one job well. Just as you wouldn't use a knife to tighten a screw, you shouldn't overload a class with multiple responsibilities. When each class has a single responsibility, your code becomes more modular and easier to manage. It's like having a team of specialists, each excelling in their own area, rather than a jack of all trades who struggles to do everything. No function should have more than one reason to change. This means that if a class is responsible for multiple tasks, it becomes more prone to errors and harder to maintain. By refactoring your code to follow the single responsibility principle, you create a more robust and flexible code base. Next, let's explore the open-closed principle. Imagine a library where books are added without rearranging the shelves. This is the essence of the open-closed principle, which states that software entities should be open for extension but closed for modification. In other words, you should be able to add new functionality to your code without changing existing code. This principle promotes the use of interfaces and abstract classes, allowing you to extend your code base in a safe and controlled manner. Your code should be open for extension but closed for modification. By following this principle, you can add new features and enhancements without risking the stability of your existing code. It's like building an extension to your house without having to tear down the walls. This approach not only makes your code more flexible, but also reduces the likelihood of introducing bugs when making changes. Now let's move on to the Liskov substitution principle. Picture a duck and a rubber duck. The Liskov substitution principle states that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. In simpler terms, if you have a function that works with a base class, it should also work with any subclass derived from that base class. This principle ensures that your code remains consistent and predictable, even when using different types of objects. Both should quack, but don't expect the rubber duck to swim. This analogy highlights the importance of ensuring that subclasses behave in a way that is consistent with their base classes. If a subclass deviates too much from the expected behavior, it can lead to unexpected results and bugs. By adhering to the Liskov substitution principle, you create a more reliable and maintainable code base. Next up is the interface segregation principle. Subclasses should be substitutable for their base classes without altering the program's correctness. This means that your subclasses should be able to stand in for their parent classes without causing any issues. It's like having a backup player on a sports team who can step in and perform just as well as the starter. This principle helps you create a more flexible and adaptable code base where changes and extensions can be made with confidence. It's like a restaurant menu. Don't force a customer to order something they don't want. The interface segregation principle states that clients should not be forced to depend on interfaces they do not use. In other words, you should create specific interfaces for specific clients rather than one large general-purpose interface. This approach reduces the complexity of your code and makes it easier to understand and maintain. Clients shouldn't be forced to depend on interfaces they don't use. By following this principle, you create more focused and relevant interfaces, which in turn makes your code more modular and easier to work with. It's like having a tailored suit that fits perfectly rather than a one-size-fits-all garment that doesn't quite meet your needs. Finally, let's discuss the dependency inversion principle. Think of it as a power strip. The dependency inversion principle states that high-level modules should not depend on low-level modules, but both should depend on abstractions. This principle promotes the use of interfaces and abstract classes to decouple high-level and low-level components, making your code more flexible and easier to maintain. It's like using a power strip to connect multiple devices rather than plugging each one directly into the wall. High-level modules shouldn't depend on low-level modules, but both should depend on abstractions. By following this principle, you create a more modular and scalable code base, where changes to one part of the system don't ripple through and cause issues in other parts. It's like having a well-organized toolbox where each tool has its place and can be easily accessed when needed. This approach not only makes your code more maintainable, but also more resilient to change. By following these principles, you'll create code that's easier to manage, extend, and debug. The solid principles provide a roadmap for writing high-quality, maintainable code that stands the test of time. They help you avoid common pitfalls and create a code base that is robust, flexible, and easy to work with. Whether you're a beginner or an experienced developer, these principles are essential tools in your coding arsenal. So, ready to make your code solid? Happy coding! Embrace these principles and watch as your coding skills soar to new heights. With solid principles as your guide, you'll be well on your way to becoming a master of object-oriented programming. Happy coding, and may your code always be clean, maintainable, and solid.